This video is going to be about solving inequalities. When we look at solving inequalities, here I have an inequality that is 5x minus 7 is greater than 3x plus 9. When I go to solve this, I want all of my x on one side. So I'll start out by subtracting 3x from both sides. I'm trying to keep my x positive, the coefficient on my x positive, so that I don't have too much work to do at the end by dividing by a negative and flipping the sign and all that. So I'll add 7 to both sides, and I've got 2x is greater than 16. And when I divide by 2, I end up with x is greater than 8. If I was going to graph this, I would look at the number line. I'd have 8 here, and my x would be everything bigger than 8. This is one way to write the notation. The other way would be to use the interval notation, so I'd have an open parentheses, and then it would still go the same way. So that parentheses is the same as the open dot. Okay, so that's one way to do inequalities. It's one type of situation. I've got a double inequality here. It's called a double inequality because it has the two inequality signs. And the way that I'm going to solve this is I'm just going to treat it like a normal set of inequalities or a normal inequality, but I'll do everything to both of them. So for example, I'm looking in the middle here and I see that I have my x in the middle, which is good. And so the way that I'll approach this is to solve like I would normally do, but apply the rules that I'm doing to each inequality. So when I add 1 to try to get my x alone, I've got to add 1 to both inequalities. So I'm left with negative 2 less than or equal to 6x, which is less than 4. So now I just go ahead and do my next step. I'll divide all of them by 6 because I'm trying to get x by itself even though it's a double. So in the middle I've got x, and on this side I've got negative 1/3, and on this side I've got less than 2/3. When I go to graph this on the number line, over on this side I've got 2/3. I'll put 0 in the middle for reference, and then this way I'd have negative 1/3, not drawn to scale. And when I've got an equal to, meaning less than or equal to here, it's going to be a bracket, and then this one will be an open parentheses, and then it's whatever's in the middle. So that's my solution set for that one. Let's look at another couple of examples. Here we're dealing with absolute value inequalities, and what we can do is we can set these up to be two separate ones. And so on one hand I've got x minus 5 less than 2. In my other one, I'm going to have x minus 5, but that expression is going to be negative, and it's going to be less than 2. So a way to think about it would be, if I take this and just immediately divide by negative 1 on both sides, I'm left with x minus 5, but then my sign flips, and I've got negative 2. So I've got an opposite of my original value, but also opposite sign. As I solve this, I'll solve it like normal. Add 5 to both sides. And so x is greater than 3, but also x is less than 7. So if I was going to graph this one, I would have 3, I'd have 7, and it's less than 7, but also bigger than 3. So it's everything in the middle between 3 and 7 for that one. Okay? That's the basic gist of inequalities. Thanks for watching, and we'll see you next time.